Hello everyone, welcome to our 6th lesson on word problems. In my opinion, this lesson is one of the more trickier ones, so I recommend that you all try the problems before watching this video just to see where you are having trouble. So we're just going to do a bunch of practice problems in this video so you guys can get the hang of the types of word problems you might encounter. Okay, so when you are looking at a word problem, I would recommend that you write down all of the information that is given to you. So in this first practice problem, we see that we have 6 more than some number. So we know that we are going to be adding 6 to something. And then we see that we're adding it to twice a number. So this number here is our unknown, so it's our x. And that's what we're trying to solve for. So since it says twice a number, we know that we're multiplying x by 2. And then it tells us that 6 plus 2x is 24. And now we have an equation to solve. So to solve this equation, we want to isolate our x. So we're going to subtract 6 from both sides. And then we are going to divide by 2. So we end up with x being 9, which is our answer. So we're going to try another problem like this. So here we see that 5 is subtracted from triple a number. So this one is a little bit trickier with the wording because it's going to be written like this, as the 5 is being subtracted from the number, not the other way around. So if you were to write it like this, it would be wrong, because this is the triple a number is subtracted from 5. And then we see that the result is 1 less than the number. So we know that this is going to be equal to x minus 1. And then we just solve this equation. So we can bring over this x and the negative 5. So we would add 5 to both sides. And also subtract x. So these will cancel and these will cancel. And we end up with 2x is 4. And then we divide by 2. So we end up with x equals 2. Now we're going to do a practice problem from last year's contest. So I suggest you guys try to do this one on your own and then come back to this video to check your answer. So with a question like this, I would recommend you guys write down everything that is given in the question. So first it says that the first term in the sequence is x. So our first term is x. And then it says that each of the following terms is obtained by tripling the previous term and adding 3. So that means our second term is going to be tripling the x and adding 3 to it. And then it tells us that our third term is 48. So our third term is 48, and it is tripling the second term and adding 3. So we triple this entire second term and we add 3 to it. And we end up with this equation here. I'm going to rewrite it. And this is what we are trying to solve here for x. So to solve for x, we're going to have to use distributive property to multiply this 3 in here into the brackets. So we end up with 3 times 3x plus 3 times 3, and then the 3 at the end. So 3 times 3x is 9x plus 9 plus 3. And then we're trying to isolate for this x. So we can add the 9 and the 3 since they are like terms, and then subtract 12 on each side. And we end up with 9x equals to 36. And then we're going to divide by 9 on each side to isolate for our x. And so we end up with x being 4. Now we're going to try a different kind of word problem. This is a very common kind of problem, so you might encounter it on the contest. So we have Drew and Kyra, and Kyra is 15 years older than Drew. So we have to write a variable to represent this, write some sort of equation to represent that Kyra is 15 years older than Drew. So if we say that D is Drew's age, then we know that Kyra's age is Drew's age plus 15. And then the question tells us that the sum of their ages is 53. So we know that Drew's age plus Kyra's age is 53. And then we have an equation here, so we can solve for Drew's age. So we have these which are like terms, so we can add them. And then we can subtract 15 from both sides. And then divide by 2. And we find that Drew is 19 years old. But we're not done yet because we need to find out how old Kyra is. But we know that Kyra's age is D plus 15. So we know that Kyra is going to be 19 plus 15, which is 34. And then if you add 34 and 19, you will get 53, which is the sum of their ages. So we're going to keep practicing with these kind of questions because the wording can sometimes be a little tricky. So here we have Jocelyn and Bincy, and Jocelyn is 8 years older. So if we say B then we know that his sister is 8 years older. And we have the sum of their ages being 62. So we know that B plus 8 plus B is 62. And then here we're solving for our variable B. So this B here and this one are like terms, so we can add them together and then subtract 8 from both sides. And then we divide by 2. And we find that B is 27. And then to find Jocelyn's age, we add 8 to it. So we know that they are 27 and 35. So let's do another practice question. Here we have Kai and Ella, and Kai ate 4 times more cupcakes than Ella. So we can make the variable E to be the number of cupcakes that Ella ate. And then the number of cupcakes that Kai ate is going to be 4 times E. And we know that the sum of the cupcakes that they ate is 55. So we know that E plus 4E is 55. And now we can solve for E. So here these two terms are like terms. So we have 5E equals 55. And so we divide each side by 5. And we get E is 11. So this is the number of cupcakes that Ella ate. And then to find the number of cupcakes that Kai ate, we're going to do 4 times 11, which gives us 44. And then if you were to add 44 and 11, we would get 55. So this is the same type of problem. So we can have M represent the number of cupcakes that Megan ate. And then Christian ate 3 times more cupcakes than Megan. So Christian ate 3M cupcakes. And then we know that the sum of the cupcakes that they ate is 72. So we know that M plus 3M is 72. And so we can solve this equation here for M. M and 3M are like terms, so we can add them to get 4M. And then we divide both sides by 4. So we end up with M is 18. So that's how many cupcakes Megan ate. And then to find how many cupcakes Christian ate, we're going to do 3 times 18, which is 54. Now we're going to look at a little bit of a more complex type of problem where we're going to need 2 equations to solve. So we know that the sum of Tommy and Rebecca's ages is 78. So now we're going to make 2 different variables, one for each of their ages. So here we have T as Tommy's age and R as Rebecca's age. So we know that T plus R is 78. And then we also know that in 6 years, Rebecca is going to be 4 times older than Tommy. So in 6 years, Rebecca is going to be her age now, which is R, plus 6. And we know that she's going to be 4 times as old as Tommy. So it's going to be 4 times T plus 6, because this is going to be Tommy's age in 6 years, and Rebecca is 4 times older than Tommy in 6 years. So let's try to simplify this equation here a little more. So here we can use distributive property to multiply the 4 into the brackets. So we're going to end up with 4 times T plus 4 times 6, which is 24. And then we are going to bring the 6 over to the other side so we can isolate for the R. So we end up with R is 4T plus 18. And now we have an R here, and this R is the same R as the R in this equation. So we can substitute this for the R here because they're the same thing. So we can rewrite this equation as T plus 4T plus 18, because this is what R is equal to here. And then now we can isolate for T. So T and 4T are like terms, so we end up with 5T plus 18, which we can subtract 18 from each side. And then we divide both sides by 5. And we get t is 12. So this is Tommy's age. And then to find Rebecca's age, we can plug the t into this equation here. So we will end up with r is 4 times 12 plus 18. And that's going to be 66. And so if you were to add 12 and 66, you get 78. So this question is where word problems get a little bit tricky. So we're going to do one more like it. I suggest you guys try and do it on your own and then come back and see if you got the right answer. So in this question, we have T being Trevon's age and R being Riley's age. And we know that the sum of their ages is 104. So we know that T plus R is 104. And then we also know that in 8 years, Riley is going to be 5 times older than Trevon. So we know that in 8 years, Riley is going to be her age right now plus 8. And we also know that she will be 5 times older than Trevon. So she will be 5 times older than Trevon in 8 years. So now we have 2 equations again. So we're going to simplify this one here to isolate for r. So here we use distributive property and we end up with 5t plus 40. And then we're going to isolate for r. So we end up with r as 5t plus 32. And then we can substitute this r here into this equation. So we will end up with t plus 5t plus 32 equals 104. And these two t's are like terms, so we can add them. And then subtract 32 from each side. So we end up with 6t equals 72. And then we divide each side by 6. And we end up with t is 12. And then to find Riley's age, we can use Trevon's age and plug it into this equation right here to solve for our r. So we end up with 5 times 12 plus 32, which is 92. Now we're going to do a question related to money. So we see here that B is going to be the number of $5 bills and C is going to be the number of $2 coins. And the total is $59. So with money, it's a little bit different because we know that we have B number of $5 bills. So we need to make sure we multiply the 5 by the B because this is the amount of money that you have. And we also have C number of $2 coins. And we know that this together is going to be 59. And we also know that Sarah has 2 more $5 bills than $2 coins. So she's going to have more $5. So here, because we have 2 variables and we have B isolated already, we can substitute it into this equation so that we can solve for our C. So we can rewrite this as 5 times 2 plus C. And then we can use distributive property. So we end up with 5 times 2, which is 10, plus 5c. And then we add these like terms. So we end up with 7c. And then we want to isolate for our c. So we're going to subtract 10 from both sides. And then we're going to divide by 7. And we end up with c equal to 7. And then to find our b, we simply substitute c for 7 into this equation. So we end up with b is 2 plus 7, which is 9. So Sarah has 7 $2 coins and 9 $5 bills. In this question, we have f as the number of $5 bills and t as the number of $10 bills. And we know that the total is $200. So we know that 5f plus 10t is 200. And then we also know that in total, Shayna has 24 bills. So we know that our f plus our t is going to be 24. And so in order to substitute one of our variables into this equation here, we need to isolate. So you can pick either to isolate for f or for t, but we're going to do f today. But you can try to isolate for t on your own, and you should get the same answer either way. So we see that f is equal to 24 minus t, and then we can plug our f in here. So we'll end up with 5 times 24 minus t plus 10t is 200. And so we're going to use distributive property. So we're going to end up with 5 times 24, which is 120, minus 5t plus 10t is 200. And then these two are like terms, so we end up with 120 plus 5t. And then we're trying to isolate for our t, so we're going to subtract 120 from both sides. And we end up with 5t equal to 80. And then to isolate for our t, we're going to divide both sides by 5. And we end up with 16. And then to find our f, we're going to use this equation here and plug our t in. So our f is going to be 24 minus 16, which is 8. So Shayna has 8 $5 bills and 16 $10 bills. So we're going to do 2 more practice problems. And the first one says that the sum of 2 numbers is 17. So these 2 numbers are our unknowns. So we can name them x and y. And we know that x plus y is 17. We also know that one of the 2 numbers is equal to the sum of 1 and thrice the other number, so 3 times the other number. So it doesn't matter if you put x or y as the number that is equal to the sum of 1 and 3 times the other number. So now we're just going to pick x. So we know that it is 1 plus 3 times the other number, which is y. And here we can substitute this second equation into the first one because we have our x. This x is the same as this x. So we can rewrite this as 1 plus 3y plus y is 17. And these two are our like terms, so we can add them together. And then we want to isolate for y, so we will subtract 1 from each side. And then divide by 4. And we get that our y is 4, and then to find our x, we can plug in our y into the second equation here. So our x is going to be 1 plus 3 times y, which is 4. And so we get 1 plus 12 is 13. So our two numbers are 4 and 13. This is a similar question where the sum of two numbers is 25. So our two numbers are going to stay x and y. So we know that x plus y is 25. And then we know that one of the two numbers is equal to the sum of 5 and 3 times the other number. So we know that x is 5 plus 3 times y. And they want us to find the product of x and y. So we can substitute this second equation here into the first one. So we're going to end up with 5 plus 3y plus y is 25. And these two are like terms, so we can add them together. And then to isolate for y, we're going to subtract 5 from both sides. And then divide by 4. So we know that our y is 5. And then to find our x, we're gonna substitute it into our second equation here and solve for x. So we're gonna end up with x equals 5 plus 3y. And in this case, our y is 5. So we end up with 5 plus 15, which is 20. And then we were asked for the product of x and y. So we need to make sure to multiply them. So x times y is going to be 20 times 5, which is 100. And that is our answer. Thank you so much for coming to our 6th lesson, and I hope to see you guys on our 7th.